All right, let's start talking through these. I'm going to do C and D first, and then we'll go and hit B, mainly just because C is like straight across from what we already did. What stands out to you about C that's different than part A that we did yesterday? It doesn't have a B value. Is absolutely correct. Give me just 1 minute. What's in between the A and the C terms? What symbol? Subtraction. So not only are we missing a B term, but we've got subtraction right here. This is a special situation. Does anybody remember what we call this type of a quadratic? And then the way we would factor that. All right, let's see if I can jog your memory a little bit more. I want you to look at the A and the C terms. What's our A value? Sean, what's our A value on part C?
Part C
Mm-hmm.
is 81x squared.
81x squared. 81's an interesting number, isn't it? What's special about 81? It's a perfect square. It's what? 9 squared, right? What do you notice about our C value?
It's also a perfect square.
It's also a perfect square.
7.
It's 7 squared. So I have 9 squared times x squared minus 7 squared. We have 2 perfect squares. This is a difference of 2. I don't have room to write perfect, but it's 2 perfect squares. And we can do the x and the area model for this, but if you have a difference of 2 perfect squares, there's a shortcut that you can do, and it's way faster than the area model and the x. Whenever we have a difference of 2 perfect squares, we are always, always, always going to have 2 factors that are almost identical. What 2 things would you multiply together that are exactly the same to get 81x squared? 9x, yes. Because we would take the square root of this first piece and we'd get 9x and 9x, because if I use my double distribution, 9x times 9x, 81x squared. What times itself would give me 49 again? 7, but we have a negative 49. Negative 7 and positive 7. The only difference between these 2 factors is that one has a minus in it and the other has a plus, so that we can get that subtraction at the end. And because they're identical, when I go to do my double distribution, because if I go to check myself, I know that 9x times 9x, that's 81x squared, plus, and then I would do 9x times 7. What's 9 times 7? 63. So I would have 63x. What happens when I distribute here, though? I get a negative 63x. What happens to these two? They cancel out. That's what them being exactly identical, except one with a plus and one with a minus will do. That's how I know. All right, so this is how it's going to factor. I'm going to scoot this down and off to the side so that I have room for my answer here. All right, so factored form, y equals 9x minus 7, 9x plus 7. How would I find the roots then? Set each one equal to 0, yes. Oh, I forgot to check for something on part C. What are we always supposed to look for first? What'd you say? Greatest common factor. Did this one have a GCF? No. Nothing goes into 89 that also goes into, or sorry, 81 that also goes into 49. So the only thing that goes into 49 is 7 and itself. And 7 doesn't go into 81. All right, I'm going to hop down to D, and then we're going to scoot backwards to B. I'm always supposed to check for GCF first. Like I said, I forgot up here. But I'm going to go ahead and write it down. Does part D have a GCF? It's 3. Is there anything else that they have in common? They have an X in common. That means it's included in my GCF. Anything that will equally divide them, which does include variables that they share. So I'm going to take a 3x out of each piece. We don't throw away our GCFs. They come out to the front. What would that leave me with? X plus 10. So how would I find the roots for that? How many factors does that have? What does the F in GCF stand for? Greatest common factor. So 3x is a factor. How many factors do I have? 2 factors. So how many roots will it have? 2 roots. We would take 3x and set it equal to 0. We would take x plus 10 and set it equal to 0. So where would these 2 roots be?
-3 and -10.
Close. -10, yes. I would subtract 10 from both sides because I want to get it to cancel there.
0.
Mm-hmm.
Because you're dividing that subtracted.
So -10, 0, there's a root. And you caught your mistake there. You would divide both sides by 3. And so we would get x equals 0. So the other root would be at 0, 0. It would be at the origin. So 2 roots. All right, last one, part B. Do we have a GCF?
Yes.
What is our GCF? 2. So we got to take that out of each piece. So I would have y equals 2, and then what do I have left over after I pull the 2 out of everybody? Beautiful. 9x squared minus 27x plus 14. Notice my GCF is still there in the front. When we're solving and I divide both sides by something, I can make GCFs disappear. But when I'm rewriting it in a new form, I can't throw that out. That's my A value. If I were to just get rid of that altogether, that parabola right there is not the exact same as the one up above it. The one up above it is skinnier because it has an A value of 2, making it narrower, stretching it up higher. Now that we've gotten our GCF out, what do I need to do with this? We're going to do the X. We're going to do the area model. So here's my A, my B, and my C terms. Sean, you're going to have to stick with me, dear. Whatever it is, it can wait. I promise. So what's going to be up on top of my X? 126. How did you get 126? Yes, 126. So we do 9 times 14 to get that 126. What goes down on the bottom?
Negative 27.
Negative 27. Those are some big numbers. What do you know about both of the numbers, though?
They're both whole numbers.
They're both whole numbers.
One is positive, the other's negative. So when you get the two side numbers, they'll be negative numbers.
Yes. The two side numbers are both going to have to be negative. Why are they both negative and not just one?
Because they have to multiply to be positive.
Has to multiply to give us a positive value. So they have to be the same sign, either both positive or both negative. What two whole numbers will multiply to give me 126, but add to give me negative 27?
Negative 6 and negative 21.
-6 and -21. Nice. I heard several people going after it. I think you guys found it faster than me. I'm absolutely 100% serious. All right. So I've got my 9x squared in here. I'm actually going to change it and write it in black because it's hard to see in red. 9x squared. What do I put down here?
14.
14. When I use the area model, I never go all the way back to the original. If there was a GCF, I don't want it in my area model. I move it out to the front, but then I don't include it because if there's a GCF still in here, I'm going to have a hard time figuring out the right things to pull out because there's going to be multiple GCFs that I'm looking for. So then I've got -6 and -21, just like that.
There should be X's.
Why should there be X's with it?
Because when you do the boxing, you'll multiply them by X.
Mm-hmm. This area model right here, this is just another way to write what I had inside parentheses. Everything in here is right here. I see the 9x squared really obviously right there. I see the 14, and I get to this negative 27x by combining those two together. They're like terms. So that area model is this. Now we're going to look at just two boxes at a time. We're going to go side to side. We're going to go up and down. And we're looking for greatest common factors again. Do you guys want to go side to side first or up and down first?
Up and down.
Up and down, sounds good. So I'm going to look right here. 9x squared and -6x. What's the biggest thing that I can take out of both at the same time?
3X.
3x. Then I'm going to come over here. -21x and +14.
Negative 7.
-7. How did you know it had to be a -7 and not a +7?
Because you know the other number will also be negative. So when you multiply that, it'll make a positive.
Mm-hmm. This is negative, this is positive. One of the things that I use to keep it straight is whatever it's touching, I have to grab that sign and take it out with my GCF. But you're absolutely correct. Your thinking is right along the right path. I just always like to come up with little ways to double check myself when I get stressed out on a test. Like, what's it touching? Take that out with it. All right, so there's one of my factors. So I'm starting to get to factored form. Y equals, we took the GCF out. And now I have 3x minus 7. And now we're going to go side to side. What can I take out of both 9x squared and -21x? 3x. -6x and 14? -2. And again, we knew it had to be a negative because it's touching a box that has a negative, and we have to take that sign out with it. If it's touching it, we got to take it out. So 3x plus 2. Do you guys have any questions for me? Oh, because I wrote the wrong thing down. Thank you, Brennan. Yes, it is. Pay no attention to the teacher behind the curtain. When my mouth and my hand go at the same time, I either say goofy stuff or I write goofy stuff. It's one or the other. I can never manage to like have my hand do something and my mouth do something else. Thank you guys for correcting me. Do we have any other questions about the bell work? Other than, Ms. Bolt, why did you write down the wrong thing? Which is valid questions. Absolutely. All right, I want you to go in your books now to page, why are you not going to the right thing? Hold up. All better now. Page 82. Page 82. We're going to look at a task called the same yet different. These sets of questions, and I want to say there's 5 questions total over 3 pages. We're going to start it today and finish it tomorrow. It's too much to get through in one day. But the goal of these question sets is to use the form to answer the questions, or perhaps to write the form to answer the questions. So we're going to be using the form or writing the form. The only thing that you may use a calculator for is basic computational facts. So things like adding, subtracting, multiplying, and dividing. But not for graphing. So they said calculators, I'm going to add, or apps. The idea is that we're making use of what they gave us. We're not going to use some other piece of software or technology to try to answer these questions. We're going to try to make sense of what they've given us to answer the questions in front of us. All right, so I'm looking at number 1. Suppose I have this equation right here. H of t equals negative 5t squared plus 10t plus 3. That's the expression that tells me what? Why do I have that?
Giving the height of a diver above the water.
Giving the height of a diver above the water. They're measuring it in meters. What does the t stand for?
Seconds after a diver reaches the springboard.
T seconds. So they're measuring time in seconds after the diver leaves the springboard. So he can stand on that springboard for the longest time, and time is not moving forward. Nobody started their stopwatches yet. As soon as that diver leaves the springboard, time starts. Before we answer question A, I just want to draw a real quick picture. I want to wrap my head around what's going on. All right, so here's my diving board, and here's my really awesome person. Isn't he amazing? Is he just jumping off the ground? What's he doing?
He's jumping off the springboard.
Jumping off the springboard. So this is like up in the air somehow, right? And it's over what?
It's over a body of water.
It's over a body of water. What's it going to look like when he jumps off of here?
Probably a curve and then down.
So he's not just going to like belly flop like this?
No.
He could. My 5-year-old would. Just straight like face plant forward into the water. Although she's gotten trickier recently. She's been learning how to swim, and over the weekend she decided to do a backwards somersault in the air into the water, which scared the pants off of me because it was a concrete edge on that pool, and she's not careful.
Oh.
She's 5.5, and we've had stitches 3 times. So I was slightly terrified. She knows no fear. All right, so if I was going to draw something that mimics this dive, you said like face planting is probably not what he's doing. So what's it going to look like?
It goes up a little and down.
It's going to go up a little and then down into the water, right? Looking an awful lot like what shape? A parabola. Would you look at that?
Never would guess.
I know, right? It's so surprising. They want me to answer how high above the water this springboard is. What am I looking for on this picture then?
The water. Is that the line you're saying?
Yes, it is. I want to know this height right here That is our y-intercept. Same thing as my initial or starting height. If you guys get nothing else from your mathematics journey at Pike High School, one of the big takeaways that I hope you get, at least from this class, if nothing else, is the starting amount, the initial amount. It doesn't matter whether we're talking about lines, quadratics, exponentials, I don't care. That starting amount is your y-intercept, always. So how do I determine the y-intercept for this? What do I have to work with? I have an equation. All right, so I'm going to recopy that equation. H of t equals negative 5 t squared plus 10t plus 3. What form did they give us to work with? Standard form. Sometimes standard form also gets called general form. Those two get used interchangeably. Can I look at this form and know that starting height? What is it? 3. This right here is my initial or my starting height. So what would my answer be here then? 3 meters. Nicely done. Standard form tells us the initial height. It's that C value. We grab it, and we're done. All right, look down at question B. Still on number 1, looking at question B. I'm going to draw my picture again. Actually, I'm going to cheat. I copied and pasted. Honestly, doing this has like ruined me with pencil and paper. The number of times that I try to like circle something and move it when I'm writing with a pen, it's like, why can't I? Question B says, when does the diver hit the water? So what am I looking for on the picture now?
X-intercept or a root.
Yes. So right here, which would be a root or an x-intercept. Can I tell that from the form they gave me? No. What form would I need?
A root form? That's not what it's called. It's not like...
We would need factored form. Do we know how to go from vertex form to standard form to factored form? What do we use to go from one to the other?
The box.
Yep, same thing that we did on our bell work to open us up. Gee, I wonder why. So what's the first thing you would always need to do if we're going to use factoring?
Find greatest common factor.
Find the greatest common factor. Do we have a GCF on this? Normally I would say no, because 5 doesn't go into everything. 10 doesn't go into everything. 2 doesn't go into everything. 3 doesn't go into everything. Not every piece has an X. What do you notice right after the equal sign, though? There's a negative. If you have a negative right here, pull that out as your GCF. Because it's never fun to do an area model, a box, when that A value is negative. It makes it confusing. Which way do you take the negative out? And so I would just rather not. So I pull that out as my GCF. So that means we're going to divide everybody by -1. So I would have h of t equals, bring that -1 out to the front. What do I have left then?
5t squared minus 10t minus 3.
And then what do I need to do?
Do the X.
Yep, do the x. So I'm going to multiply two pieces together and get what?
Negative 15.
Negative 15, because I do 5 times negative 3. I'm going to scoot this just a little bit. See, this is why I'm so spoiled about it. I have 5 times negative 3. I get negative 15. So I'm thinking up numbers that multiply to give me negative 15. Has to add to be what?
Negative 10.
Well, there's only a couple things that multiply to give you 15, right? What are some things that multiply to 15?
5 and 3.
5 and 3. Is there any way I can take 5 and 3 and get 10? Nope. What else could possibly multiply to give me 15? 1 and 15. Is there any way I can take 1 and 15 and get 10? What does that mean then?
You have to use quadratic formula.
Yeah, which we're not going to do right now. We're not doing that until after break. But it does mean that this does not factor. That doesn't mean that it doesn't have any roots. We talked yesterday about the situations where I can't have factored form. One is where there's no roots. How do I know this is not one of those situations? Because what? Yeah, the diver is going to hit the water at some point, right? What about instead of solving exactly, what could I do if I wanted to try to estimate this? What could I do to estimate when he's going to hit the water? Yes, we could try guess and check. Quadratic formula will find it exactly. So I'm going to write that down here. I want to do a little bit of guess and check and see if we can ballpark about when he's going to hit the water. So I'm going to have a table with x's and y's. Oh, wait, no, it shouldn't be x and y. It should be what? H and t. Does h go over here and t over here? Other way around. So t here, h here. Do we already know how high he's going to be at time 0? 3 meters. Because we said that was our initial height, right? What else should I try if I'm doing a guess and check for when he's going to hit the water? What should I try? 5?
Yeah.
Okay, let's try 5. I'm going to put that down here, though, so that I have room to fill in the middle in case I want to. So what am I going to do with that 5? Yep, we're going to put it in for t in the equation. So in this equation, h of t, I have negative 5 times t. We're putting 5 in for t. Squared. Plus 10 times, we put 5 in here also. Anywhere I see a t, I replace it. Plus 3. Order of operations says to do what first? Squaring. Exponents come before we multiply or divide. So what is 5 squared? 25. So then I take 25 and do what with it?
Multiply by negative 5.
Multiply it by negative 5. What is 25 times negative 5?
Negative 125.
Negative 125 plus 50 plus 3. What are we getting as our output here?
Negative 72.
Negative 72. What does that mean?
You already hit the water and you need to go smaller.
That we already hit the water. Assuming that hitting the water didn't slow him down, he'd be 72 meters underneath the water. I hope he's in the ocean and not the pool. So what else can I try?
1.
1. Sounds good. So So we're going to do the exact same thing that we did before, but we're going to put a 1 in everywhere that we saw a T. So I'm going to square the 1. That gives me what? 1. 1 times negative 5. So I have negative 5 plus 10 plus 3. We get 8. So he hasn't hit the water yet. What else should I try? 2. So same thing again. Oh, that's not what I wanted to do. I'm going to move it up here. So we're putting in a 2 everywhere we had a T. So we square first. What's 2 squared? And then 4 times negative 5. Negative 20 plus 20 plus 3. What do we get? 3. Has he hit the water yet? What do I do? Try 3. So I'm going to square the 3 and then multiply it by negative 5. What will that give me? Negative 45 plus 30 plus 3. We get negative 12. Has he hit the water?
Yes, he's like 12 meters below.
12 meters below the water. So somewhere in here, he hits the water. I don't want to keep guessing and checking because I'd like to finish up this page before the end of the day. But if I was going to keep guessing and checking, could I get more precise?
Yeah.
Should I try numbers that are closer to 2 or closer to 3?
Closer to 2.
Closer to 2. Why?
Because the 2 is almost near 0, while the 3 is like at 12.
Absolutely. All right, so look down at question C. At what time in the diver's descent towards the water is the diver again at the same height as the springboard? Did we find that?
Yeah.
Yeah, we did. Doing our guess and check. We got it right there. So at 2 seconds. How could I have done that if we hadn't saved this table with the guess and check? How could I use the equation, the form, to determine this? What was the diver's initial height? 3 meters. So I could put 3 meters in the place of the height. So I'd put 3 in over here. We always want quadratic equations to be equal to what? 0. So I would subtract 3 from both sides. What happens when I subtract 3 from both sides? Both of these 3's cancel out. So I get 0 is equal to negative 5t squared plus 10t. I couldn't factor the original equation, but can I factor that? What can I take out of both pieces? Close. Negative 5t. So I would have 0 equals negative 5t times what? What would be left over? T plus 2 minus 2 plus 2 minus 2. What would I do with each of those factors now? Yep. Set them equal to 0, so negative 5t equals 0. T minus 2 equals 0. And solve them both for t. And I get that t is 0. Well, we knew that already. He started at 3 meters high. And t equals 2. So at those 2 times, he's 3 meters up. All right, last one. I know bell's getting ready to ring, but this will finish the page out, and it's fast. When does the diver reach the peak of the dive? That'd be my vertex form, but look at what we came up with our guess and check. We got 8. What do we know about parabolas? What do you know about the 2 sides of a parabola? Yep. Here's my vertex. And right down the middle, there's this line of symmetry. So if I can find something that's the same height on either side, halfway in between, the vertex has to be there. So we had 0, 3, and 2, 3, which means my vertex has to be halfway in between, 1 something, and we found what that was. We found that to be 1, 8. So at 1 second, we have the max height of 8 meters. All right, we're going to pick up with page 83 and 84 tomorrow. So come in ready to get started on page 83. Have a great rest of your day, guys. I'll see you tomorrow.